going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Kevin Wittek, and after working for many years in the industry as a software engineer, I went back to academia, where I'm now pursuing my PhD in the field of blockchain, and I'm leading the blockchain research lab at the Institute for Internet Security at the Wittek University of Applied Sciences in Germany. But luckily or sadly, today I will not talk about blockchain. Instead I will talk about Testcontainers, a widely used and established open source library for easy use of Docker containers for integration testing need, end-to-end testing need. And I'm normally talking to software developers, but I'm very happy to have this topic here towards a more testing-oriented crowd. And I hope I can show you some cool things and you can find some things you like and you can maybe apply in your jobs. So have fun! Okay, hi, hello everyone. I'm happy to be here at the first testing conference I ever spoke at. So I'm a software developer by trade normally and speaking at software developer conferences. But yeah, it's cool and it's great for me to be here. Yes, if you have any questions, put them in the Slido, or I'm not sure if I could see questions you write in the chat, then I would also be able to address them or whatever. Let's just dive in and start. Today I will talk about integration testing using Docker and test containers. And before we start, a little bit about myself. My name is Kevin Wittek. I'm a doctoral researcher at the Institute for Internet Security, which is here in Germany at the Westphalian University of Applied Sciences. And there I'm leading the blockchain research lab. And I'm also at the same time doing my PhD. But I actually have a background in software engineering, working in the industry, and I just recently, last year, came back to my old university to go back into research and do my PhD. And it's kind of a fun and passionate thing for me because I'm interested in research and science, and that's why I went back. And yeah, some things are better in academia, some things are better in industry. It's just different in the end. Still, I'm also a consultant at the same time and coach doing for clean coding and these kind of topics. And I'm at the side doing kind of a blockchain startup-y thing. So when you do blockchain, you have to do some blockchain startup. But in addition, I'm one of the maintainers of the Testcontainers project. In general, a big open source fan and open source contributor. And therefore, I hope I'm in a good position to tell you some things about test containers here today. And I'm an Oracle Groundbreaker ambassador. It's, I don't know, people that talk at conferences, sometimes they become this Oracle Groundbreaker ambassador role. Yeah, so one of the last things when I was still working in industry that happened to me related to a testing accident, incident, however you would call it, was in my last job where we were developing software for milking robots. And we were not developing the software that would run on the robot, but we were developing the software that was running on a management server that would contain all the business logic. So in Germany, we have this, or it's actually worldwide, there are these automated milking robots, like the cow just goes into the robot, basically. It gets food there and it gets automatically milked. It's pretty cool from a technology standpoint to a certain degree. And there is quite some business logic involved in this as well. So depending on how much milk the cow would give or what kind of cow it is, it would get different amounts of food, different food compositions. There are different kinds of food. And this kind of business logic is in the server, and the robot asks the server, okay, how should I treat this cow now in this milking incident, in this milking event? And what happened is we had this robots in some test farms, dairy farms, and with the software deployed and everything. And then we got a call from one of the farmers, and he said, oh, suddenly this one kind of food is empty all the time. What happens? Okay, then we checked the logs, and we found out, okay, every time a cow enters, it gets the maximum amount of food. And then we even found out, okay, luckily we had a maximum threshold, because from the calculation it would have gotten, instead of the 5 kilogram, it was the maximum amount 25 kilogram. So yeah, like a big buck was there. And we tried to find out, okay, what is it? So we had tests, we had everything. We had tests, we had automated tests, we had a manual tester in the team, but still something weird happened. And then we found out that there was a certain condition where we would basically have an off by one error in a SQL statement when checking the database. So when the cow would enter, we would check former visits, and based on this, calculate how much food it would get. There was kind of an off by one error, thereby missing the last visits, and always thinking like, oh, the cow hasn't been in here forever, let's give her everything. And that was the problem. And yeah, this was a problem that was not found by our automated tests, because basically we did too much mocking. So there were too much mocks and stubs involved. Instead of testing really the logic of the SQL statement, we were just testing the mocks, and that was of course a little bit stupid from our side as well. And then it ended up with us having to do the patch. And deployment on a milking robot is not a cloud deployment or anything. No, it's you drive out to the farm, you go into the cow shack or whatever, through the cow shit with a USB stick, and you update the server. So that's what happened there. And definitely this was something that could have been prevented with a better automated testing coverage with regards to integration testing. So in general, I normally speak to developers, and I want to motivate developers how they should set up their projects and environments. I assume a lot of you are part of the same team, of the team of the developers as well. So you're impacted by this as well then. And what I want to say, or I want to provoke the idea that nowadays we should be able to set up projects in such a way that they are such nicely configured and automated that everyone joining a project should be able, by just cloning the project and then running the build, should run the build, should run the test, should run the integration test, maybe even some acceptance test, functional test, whatever, without setting anything up, without running through many pages of wiki articles or whatever that tells how to set up system. No, it should all be self-described by code in the repository. And I think nowadays we have really good tooling and really good software that allows us to achieve this. And if we have this way to basically spin up testing environments, especially integration testing environments, from zero anywhere just by running the build, it might be that it becomes easier and better to also write integration tests and do more integration testing. And maybe more integration tests gives us better confidence. But like, this is my personal view. Probably testers might have different view with regards to where the focus in the testing pyramid might lie. So I'm very interested in hearing your thoughts about this stuff after the talk, if we engage in discussion in the Zoom channel or wherever. So yes, this is the testing pyramid as I know it from back when I was in university. Like, that's how it got taught to us. And of course, like we have this mainly unit tests and then less integration tests, less UI tests, and so on. And I don't know how it is with testers, but with software engineers, or like developers, those different layers are not really that clear cut. Like different people, different teams have different definitions about where the boundaries of the layers are. So this is the first problem. And this shape is in a certain way maybe historic. So it at one point was probably a good idea to have this shape, but maybe we can challenge also the idea of having this shape as the optimum, and maybe can have different shapes depending on our needs or depending on the current state of technology. So with the test container stuff I'm showing today, I'm talking about integration tests. And I said before, like different people have different definitions of integration tests that sometimes differ extremely. So I like to give you my definition that we are all on the same page. And for me, integration tests are those that are mostly interacting with other components out of processes, out of my process, with code that is not in my control. So the best example are interacting with a network, with a file system, with a database, with other systems, etc. That for me are the obvious integration tests. For me is not an integration test if I have two different classes or two different objects that are from my code that are interacting with each other just in memory. This is for me a unit test. But some people already call this an integration test because you're integrating classes with each other. For me, that's not. For me, integration test normally means interacting with systems that are outside of my control, outside of my context, probably outside of my process. And yes, there, I said before, like pyramid, does it always have to be a pyramid? So I would really like to discuss these kind of things with you to get the view of the testers on this as well. So bring in the questions, join the Zoom chat later. This is from a blog post from Spotify where they described how their test suite looks. And as you can see, it's not a pyramid, it's a honeycomb or something like a diamond. And implementation detail here is a unit testing, and then integration is the integration testing as I defined it. And integrated testing is like a new class of tests that I will define on the next slide. Maybe you never heard of it. I haven't heard of it before the blog post as well, but I like this distinguish these different classes of tests. And they say they mainly use integration tests for testing their microservices, because they say automated integration tests, obviously. And they say it gives them a better confidence in the correctness of the behavior of the system, as well as allowing for a lot of agility with regards to refactoring and replacing parts of the code or complete services, because they are mostly even focusing on black box integration tests, and then they can just swap out a microservice, put in a new implementation, still reuse the same test suite, and so on. And this is especially more agility for refactoring as compared to having those stub and mock intensive tests that are always kind of bringing stronger encapsulation between code and tests. Yeah. And they are using Docker and test containers to allow for this nicely decoupled integration test. That's what they say also in this blog post. Now this integrated testing. So maybe if I bring out this definition, you will say it's bullshit, but I like it. And I like to bring it to the table and introduce it to the community. And this integrated test definition comes from JB Rainsberger. He's a guy from the Agile and test-driven development community. And he defines it like this: I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior. So these integrated tests are kind of an anti-pattern. You want to avoid them as much as possible. And Spotify has an easier definition saying a test that will pass or fail based on the correctness of another system. So you don't want to have those automated tests, because if they fail, you don't know, is it because I changed my system and my code, or is it because the other system changed? So the examples for these integrated tests happen, for example, as soon as we require to spin up certain local services or local testing environments or configure them. Because as soon as I make a mistake in spinning those up and configuring them, my test will fail. Although my code was not changed. My code is still correct. I just made a failure in setting up my test environment. So that's not great. We don't want to have those. And shared testing environment to a certain degree also lead to this, especially if you run concurrent tests in a shared testing environment, and tests from other tests or other teams testing might leak state and changes in there that will then break your test. That's also not good, because then you don't know, did I make the mistake or did the other introduce this change, and so on. And at one point you probably want to have this and need some integrated test, because you want to test everything in complete integration. Yeah, so it doesn't mean you don't have to have, you should have 0 integrated tests, but you should minimize them, and they should not be part of your regular testing feedback loop. Looking from a developer standpoint here, yeah, where I want to run actually my tests every time I make a change in the code. And then I want to 100% trust them, because they are part of my feedback and development loop. Okay, so now how do we achieve it? What magic tools do we need for this? So actually, I'm coming from a Java world, so I'm looking from the Java lens here, but the patterns can be, of course, applied in other languages and technologies as well. And basically what I just want to show is, okay, use the normal test framework you already use currently. Like in Java, we use JUnit or sometimes Spock or something like this. Just use the JUnit, the basic developer testing framework, and just combine this with Docker and instrument Docker with test containers, and then you're solved. So you don't need other systems. You can integrate with your existing tool set and your normal developer testing tools. So I'm not diving too deep into Docker now, but basically Docker allows us to implement this paradigm, mostly because of the fact that, as compared to before, infrastructure as code approaches with Docker are much, much easier to execute. So the idea what we will do, we can do it as well with virtual machines. We can define environments with virtual machines using infrastructure as code approaches, but instrumenting, creating virtual machines is a little bit too slow to do it effectively at a bigger scale and with with fast feedback cycles. So Docker containers just help us tremendously by making the creation and instrumentation of containers so lightweight. And we just want to use the containers to instrument other applications mostly. Yeah. All right, genau. So yes, the goal is, if you start a project and you start developing with a project, the setup of the development and test and build environment, it's all kind of included. You just clone the project, you build it, and then it works, and you don't need to configure anything else. Except, okay, now you need Docker, but you don't need to install the Postgres database. You don't need to install, I don't know, the Nginx web proxy or whatever. Yeah, it should be all be part of your code and your test suite execution. And test containers allows this very nicely, but the paradigm could be transferred and re-implemented in other technologies and languages as well. So how does test containers look in a nutshell? Now we will see Java stuff and Java code, because it's mainly a Java library. And here we see it's basically an object-oriented abstraction on top of Docker from within Java. As you can see, you can just create a container as an object here. You say for which image you want to have it, which ports it should expose, and then you can instrument it. You can start it, stop it, or do other stuff with the container, whatever you want. Now, a very important thing that is happening here, if we check at what happens at the start is not meaning to just start the container. It starts the application in the container as well. It is a synchronous blocking call. So normally when you execute, you create and run a Docker container on the command line, it would directly create the container and then be finished. And Docker doesn't know anything else. It knows how to create and start containers, but it is not aware of applications running inside the containers, at least not by itself. only if you would use something like a health check. So if you would now naively just say, okay, before the test, I want to start all these containers with which my test will interact, and just by doing the Docker run, then you are building directly a race condition into your test, because you will not know if the application inside the container is actually running. And Testcontainers supports a pattern there called wait strategies, and it blocks this synchronous start call until the application inside the container is ready, fulfills the wait strategy. And what does this mean, this wait strategies? These can be very naive things, like the easiest one is just checking that the TCP port is answering. In this case, that this port can be connected to. But there are also complexer ones, looking for certain log messages, looking for certain HTTP responses, etc., or even checking for certain JDBC, so SQL statement and SQL results. And yes, and when I stop the whole thing, the container gets stopped and also cleaned up, so we clean up all resources afterwards. Testcontainers Java has been first released in 2015, and it's 100% here by this guy, Richard North. And it's a 100% open source project. It's MIT licensed. We have over 65 releases. It's a very active open source project with a lot of community around it, a lot of community involvement. And we have 3 core maintainers, Richard, Sergey, and me. I joined last, and we all do it in our spare time, basically, as, I don't know, hobby, passion, however you would call it. There is no commercial involvement from our side, although we recently started getting in touch with GitHub sponsorship program, but yeah, not too much sponsoring rolling around yet. And it's a Java library, and the main feature set is in Java, but there's also forks or implementation, or however you would call them, in other languages, but they are not maintained by the main team. So I can't really comment on the quality or of the feature richness of those others. Yeah, a lot of stars on GitHub. We saw the example that was the generic container support, so everything that has a Docker image can be used with Testcontainers. But we also have specialized support for certain technologies, like different databases, SQL databases, NoSQL databases, things like messaging stream processing platforms like Kafka, Pulsar, AWS, and so on. And those specialized implementations, they give you a little bit nicer APIs. And they also have things like these wait strategies I mentioned already included. And maybe they are working around some of the limitations of the Docker images, because not every Docker image that is out there, not every official Docker image that's out there even, is very well suited for being automated or being used in automated testing. So we work around these kind of things. Yeah, Selenium support is pretty nice. So you can then run the browser inside the container in a pseudo headless mode. That's pretty nice. Chaos testing using Proxy. You can then drop packages in the network. Cool stuff. Another nice thing is we use kind of a dynamic port binding feature. So normally when you bind a port in Docker, like say port 5432 of Postgres into the 5432, you in this moment on the host, you in this moment directly create an integrated test again. And this test will now fail if this port is already in use. Why could it be in use? For whatever reason, maybe because you're parallelizing test, or because you have something else running, or whatever. So you directly create an integrated test, and that's not nice. So instead, what Testcontainers does, it doesn't use this fixed port mapping of Docker. It uses a port publishing feature of Docker. There you just say, okay, I want to interact with this port, and then Docker basically maps it automatically to a free port, an ephemeral Unix port, something about 30,000 something. And then Testcontainers provides an API to get the actual port. And thereby you avoid this integrated test trap. So wait strategies are already mentioned, And what is very great, it works in all Docker environment, and it has Docker environment discovery built in. So test containers will look what kind of Docker installation you're having, like Docker for Windows, for Mac, or Docker machine or something, and then configure itself accordingly to interact with the Docker daemon. And therefore, it also supports all operating systems like Linux, Mac OS, Windows 10. Yeah, works on Windows 2 now, really great with the npipe support. And the new Docker for Windows with WSL2 works really great with test containers. And also in the CI system, it works the same way. Like as long as your CI system has access to Docker, test containers will work as well. A lot of different users we can see here. And now besides this general integration, we have also a more test framework specific integration where is the starting and stopping of container is attached to the life cycle of your test framework. So in this case, JUnit 4 rules. In the case of the class rule, it would start the containers before, annotated containers before the test class and stops them afterwards. You can also say add rule, then it will start and stop between test methods. And while it's still fast, of course, we will see in the demo in a bit what this means. This is Spock with another Java framework. There's a new JUnit 5 Jupyter. Similar integration capabilities we have there. But I'm much more interested to showing you now an example. So therefore I will do this. Let me stop share. I share again. Application window. Oh, where is it? So I want to, but it's actually not showing. My window is not showing how I... Oh, now it's there. Okay. All right. So yeah, I have a Java project here. So first of all, if you're in a Java project, all you need to do to, whoopsie, where, let's check here. If you're in a Java project, all you need to do is add a Maven dependency, like the test containers Maven dependencies, then you're good to go. Nothing else you have to do, nothing to install. It's all managed by the Java build system. Yeah, and now I have a super stupid example application, and it's just a book class with two fields, name and author, and then I have a book repository that can then save the book in a relational database, Postgres database, and I have no framework stuff here whatsoever inside. It's just like plain Java SQL classes, and this will just use SQL statement to interact with a relational database. We have methods like save, count, and find for searching like an author. And now we want to test this class. So this production code is not really interesting. We don't want to look at this. Let's look at the actual test class. Okay, so now I have here the test class. It's annotated with Testcontainers, so I'm enabling the JUnit Jupyter extension from Testcontainers by this. And now I have a field here with a container, PostgreSQL container. That is one of the specialized Testcontainers implementation that already then includes the Postgres image and configures it accordingly and has some nice API method like this one, get JDBC URL, etc. And by annotating it with add container, it will start and stop the container in between tests, basically. And now, before every test, I will set up a database schema, database migration using Flyway here. And yeah, then I have a couple of tests. I'm testing an empty repository is empty. And after I save one book in a repository, there's one book. And if I have multiple books in a repository, I can search for a book accordingly. So let me run this. So now the test starts, and we already see some logs here from test containers, some Docker stuff. We see something like, okay, container starting, yes, done, Flyway migration finished. Okay, next test done. Yeah, and it just happens. And if we would look at the same time, and maybe I can do it. Give me a sec. I do this, and then I do here terminal. I say here watch Docker PS. Then we see here the Docker containers popping up. Yeah, this is a Postgres container created less than a second ago, up 2 seconds. Now it will be gone. And now the next container will come. So we see test containers under the hood, kind of managing the containers, throwing them away afterward, and so on. And we have here one additional container, Ryuk. This is a helper container from Testcontainers we use for resource cleanup. Okay. So, but now we saw, let's see the run window. Maybe I have to run again. So we see it's a little bit slow. Each test takes a couple of seconds. That's much too slow for the normal development lifecycle, I would say. Like we want to have test execution in sub-seconds to get the fast developer feedback. But the time is still okay if you consider that every time we get a complete brand new database instance, yeah, it's not only a new schema, it's a complete new database, a database container. So considering this, the time is okay. But in reality, we want to improve this considerably. And one easy way is by just already reusing the same container in all tests of the classes. This I can do by making it a static variable. Now it will be shared throughout the whole test class. And now what I want to do in the before each, I still want to avoid test pollution, but why avoid test pollution at the infrastructure level by throwing away the infrastructure? That's expensive. Let's try to avoid test pollution on a logical level. So now I will do a Flyway Clean that's just like cleaning the schema. So I'm still recreating the schema now every time, but I'm reusing the same database instance, the same container instance. And if we checked here, it was 18 seconds, the whole test class. So I'll run it again. Now the test class is much faster. It's like 1 second something. It's even too fast. I think there's something wrong with the reporting, but just by watching, we saw it's considerably faster. So definitely try to reuse the container. Just because now it's programmatically cheap to define that you want to have a new container for every test, doesn't mean you should do it, because it still is expensive for the computer to execute those tests. And in the documentation, we even provide another way to, we call it singleton container pattern. And in this way, it would reuse the same container instances for all tests within the same JVM process. And that is what we generally recommend. It is the best and most efficient way to use test containers. So I see I'm slowly running out of time. So let me show you another cool example, which is a bit more a black boxy acceptance testing thingy. And I'm having a voting application, so I don't want to change again the screen, and I have to reshare. Let me just try to, no, I should do, wait, give me a sec. Okay. No. Okay, let me just execute the test and I explain you, and then I will show you the video, hopefully, and that I can do with the recording. So I have now another test that will, damn it, this is not configured. I can still show you the video though. So this is now an acceptance test that uses Docker Compose container. So I'm having a Docker Compose file here that then Testcontainers will instrument. The Docker Compose looks like this. I have a couple of different services, 2 different front ends, different back ends, and so on. And now the Compose will basically start up all these microservices, this microservice-based system. And then we want to run browser-based tests against this. Okay, and let me try to re-import, and maybe then it works. So why is it currently not working here? Because I updated my IntelliJ, and when you update IntelliJ, then sometimes the Groovy integration breaks. So it's a problem here. That's why everything is red. But in the background, I'm just re-importing, and then it should be fine, I hope. let's see. So whatever, I can go on explaining the code while it's importing here. So I'm starting here this Docker Compose container that spins up all the services. Then I'm using another special Testcontainers container, browser WebDriver container. This one contains a browser with an installed Selenium inside. And it will render everything. Yeah, it's coming. It will render everything inside into a virtual frame buffer. So it's basically headless, but it's still rendering everything into the frame buffer. And then at the same time, Testcontainers is starting a VNC container that connects to this browser container using VNC as a protocol over the Docker network and records the whole session as a video. And then you can see the run afterwards. So let me just run it now. It seems it imported everything correctly. Okay, I have now, this is a JEP as a test framework. I'm checking these different front ends. It's like voting. You can vote for 2 options. I'm checking these different front ends. I'm checking the results. Okay, it was just some Windows pop here. I'm checking the results. And yes, it's running. And then I'm going to the website. I'm doing some of the voting. I'm checking that the result changed accordingly. Those leaped everywhere. By the way, it's just that we will see something in the recording. So okay, this test now run. Everything run. Kind of headless. Nothing popped up here. But as I said here, like with recording mode. So we will see here in test results that I have now here a couple of video files. There are some of my old test runs. Let me open. It's this one. And now, okay, let me now just share the other screen. Okay, so this is a recording from the test run. Okay, and here you see what was happening in the browser. And now the beauty of the setup is you can just go and clone this project from GitHub. I have it on GitHub. And if you just run the Gradle build, it will work directly on your system, assuming you have Java stuff and so on at least, and Docker. So you don't have to have the browser installed. You don't have to configure the WebDriver for Selenium, etc., etc. And I think that is pretty nice also. All right. So we are running out of time. So let me wrap up. There would be a lot of stuff I would like to talk with you. So just ask questions now and then join me in the Zoom sessions and we can discuss many details, also specific things. So I'm jumping about the stuff. I showed you different stuff. Yes, you can also use CI. Even if your CI runs inside a container, you can also directly use test containers, no problem. Different strategies for this. Docker and Docker wormhole pattern. This is CI specific stuff. Like the people who set up the CI, they should know how the CI is set up and then they can make it work. It always is workable, but you have to understand how your CI is set up. Yes, so yeah, that I could talk more about the future, where we're going to, etc., supporting other engines. But since we are running a little bit out of time, I'm skipping this. Just what I can say, probably a Kubernetes support is not coming soon because we don't have the resources to support Kubernetes specifically. Yes, thank you very much. It was nice giving a talk here at this conference. Of course, would have loved to give it in person, but maybe another time in the future or in the far future. Let's see how everything plays out. Here we have this sponsoring setup for test containers. If you use it in your company or whatever your company would be interested in, sponsor the project with $5 a month. We would be already super happy. And I'm starting then the Q&A now. So I already see some questions. Someone wants to have the resources. Let me check. Do I have the link? Yes. So just here, I can maybe also copy paste them. Can I answer them here? No. I put here in the chat. I'm not sure if you can see and access the chat. But whatever, here, check them. And the examples are, this is the GitHub Testcontainers, of course. This is the normal integration test example. This is the example of the acceptance test, is another integration test example. Yes, check out those 3 of my repositories. Okay, next question. How much time does it take for a complex situation? There is no direct answer. So I did run it in my last job before I joined academia for production systems. And we had Kafka and a couple of microservices. That was mainly like Kafka as the integration bus. And you have, at one point, you have the static overhead of setting up everything that gets added to your test suite, which is maybe really depends on your system and on your data. Can take a couple of seconds, can take a minute, can take 10 minutes if you use Oracle database. Then it becomes painful, of course, and you have to think about how to optimize it. But once it's standing, then it's as fast as those components are, of course. So it is adding overhead. It is adding overhead as compared to an H2 in-memory database and so on, of course, but it is giving you much more confidence. Like I much prefer to test my SQL statements against Postgres instead of testing them against H2 in-memory database in a Postgres compatibility mode. Okay, then how tempting is it to avoid writing unit tests? It is tempting. But so yes, in the last project, we were then mostly writing more end-to-end tests or like gray box integration tests or however you would call them. So yes, it is tempting, but so you have to check at one point, does it make sense to do still the integration test here, or can you make a real good unit test? In my opinion, it is better to write integration and end-to-end tests instead of using a lot of mocks and stubs. This is a hill I'm willing to die on. I'm really sure about this. But if you have clear logic that is inside your class, definitely go for unit tests and still engineer those components that they are unit testable. But yes, it's a slight danger. If writing integration tests becomes easier, then people tend to become a bit more lazy, write more integration tests, and at one point your whole test suite will be slow. You're in the multiple minutes area. And that's not where I want to be. I want to be in the multiple seconds area in general. Or at least for my normal cycle. You can still think about having the fast cycle and then another test suite that you just run before committing or just run in the CI and so on. Yeah. All right. Okay, since there are no more questions, I would now jump into the Zoom session and then we can go on talking there. Let's do